Now, sometime when we multiply two matrices together, we don't want to get the entire product. We just want to get part of it. So I'll show you some shortcuts in this example. So I've got matrix A and B that maybe you'll recognize. They're taken from the previous video. And we actually did calculate A times B completely in that other video. But let's say I want to calculate only a specific entry of AB. Maybe I want to calculate the entry 2, 3. Okay, let's make sure that actually A times B makes sense. Okay, once again, A is what, 2 times 3, B is 3 times 4, and the inner dimensions actually match. So we're going to get a matrix that's 2 by 4, right? So AB is going to be 2 by 4. So it does make sense to talk about the entry 2, 3. Okay, so how do I get entry 2, 3? Well, I'm going to have to essentially multiply these entries with these entries to get 2, 3. So it's going to be equivalent to multiplying the second row of A against the third column of B. And if I do this, I notice that how this looks like a dot product in some way between two vectors, and actually we could write it as a dot product. So this is 2 times 4 plus 6 times 3 plus 0 times 5. So this is 18 plus 8, so 26. So we get the value without having to compute the entire matrix product. Okay, it occurs often when we have like very large matrices, even on a computer. Let's say we have a matrix that has like more than 100,000 rows, and that's sometimes possible in applications. And we've got another one with a lot of rows and columns, and we don't want to ask the computer to compute the entire matrix product. Like, it's going to be a huge amount of calculations to do just for the computer. So we can, if I just want a single entry, okay, it will take the computer a lot less time if I just choose the right rows and columns to multiply. Okay. So notice how this is the second row of A, and notice how that's your 2 here, and this is the third row, third column of B, and notice how that's your 3 here. So when we have AB 2, 3, right, second row, third column, it's very easy. You take the second row or the of the first matrix, third column of the other matrix. Similarly, if I would have, like, you know, AB IJ, I would be multiplying. That's going to be we can write a little formula here: ith row of A times the jth column of B. So that's the little formula to retain from this example. Now suppose I want the second column of AB. Okay, second column. How am I going to get this? So you have to realize, right, I've got A, I've got B. How do I get the second column? Second column, I need to multiply all the entries of A against the second column of B. So it's going to be A times the second column of B. So it would be what? It would be, okay, let's write this. So this is what you're calculating. A times the second column of B, we're going to get 1, 2, 4, 2, 6, 0 times the second column of B, which is 1 minus 1, 7. Doing this, we're going to get 27 minus 4. And how do I get the first row of AB? Well, first row, I'm going to have to multiply, let's go back here, all this row against all the columns of B. So essentially, again, all of B itself. Okay, so I need to multiply first row of A times B. So it'd be what? First row is 1, 2, 4 against all of B. So 4, 0, 2, 1 minus 1, 7, 4, 3, 5, 3, 1, and 2. And if I do this, I'm going to get 12, 27, 30, 13. Okay, so I hope you see the pattern that emerges from this. If I want the, let's say the jth column of AB, well, I'm going to have to multiply A times the jth column of B. So that's the formula that emerges from, comes out of this. And here, if I want the ith row of AB, is going to be the ith row of A times B. So these are three shortcuts if we want just part of the product.